Alright guys, so in this video, we're going to talk about how to compare objects. So as you guys know, usually when we compare objects, the dot equals method is what we use. And this is a way right here that we could compare two objects by actually looking at their instance variables. So we compared one person's name to the other object's name. So the current object's name, so if you call, like, if you have two people, if you call A dot equals B, then B is the other, and A is like the this that you're calling it on. And it compares their names. Now, you might have wondered, what does equals equals actually do? So we're going to talk about that today. So what happens is that equals equals actually compares the memory addresses. Because what equals equals does is the equals equals compares the contents of that variable. So looking back at like our example from earlier, when you call equals equals on these two variables, like if you have an int, you're comparing, this value here to this value here. But if you have an object, you're comparing the memory addresses here and asking, do they point to the same spot in memory? Okay, so that's what's going on, which is a memory address for objects. Okay, so if we have some people, so let's make some T. Okay, so let's say we just have person T1 to be a new person, and let's call that to be Mr. Herzog, the living legend. Okay, now I'm going to make another Mr. Herzog, so I'm going to make person T2 to be, again, the same person Herzog. And now I'm going to set another person T3, and I'm going to set that to equal T1. And as we saw in the last video, this copies over the memory address. The spot that T1 was pointing to, now T3 is going to be pointing to that same location. So now we know the dot equals will be true for all of these because they all have the same name. But then what about equals equals? So let's just go ahead and see what prints out if we do T1 equals equals. Well, let's do some obvious cases, right? I think we can agree that this is going to be true because they point to the same spot, because they are the same address in memory. Okay, but what happens if we print out whether T1 equals T3. And by the way, the reason these are going to print out is that Java just treats this like an if statement and just turns it into a true or false and just prints that out. So when I run this, it sees they're both true. Because again, these are true because T3 points to the same spot as T1. And of course, even if I go ahead and change something, right? If I change like T1's name to be another legend Kirby, we're going to see, of course, the same thing happens. Now, if we try and print out, though, like T1 equals T2, what that is going to do is that's going to be hopefully false. Or I taught this whole lesson wrong. Good, it's false. Okay, and that happens, of course, because T1 and T2 point to different spots in memory. All equals equals is doing is comparing the memory locations. And this is why equals equals doesn't work with strings. They're just different spots in memory. So that's what's happening here. Equals equals is actually trying to compare the real memory location. And if I want to compare content, I would need to use dot equals. And we've written plenty of dot equals methods before, and we know how they work. Okay. The other thing I wanted to point out and talk about is the keyword null. And you guys have seen these before, null, for example, in the null pointer exception. So null means it points to nowhere. It is a memory address. So you can only use it with objects, not with primitives. So what I could do is I can set up, for instance, like, I don't know, string nothing to equal null. And I can set up a person no one to equal null. And those will compile and those will be fine. But I cannot do it with objects, or sorry, with primitives. So if I try and set up, a Boolean b to equal null, that actually doesn't work. Java won't let that compile. It'll give you this error, incompatible types. Oops, where'd the error go? Oh, it's been so real. Okay, sorry, it gives you this error. A null cannot be converted to a Boolean. Okay, so that does not work. And what's kind of interesting is if you print out a variable that is null, it will always say null. So if you try and print out, let's say nothing, and then let's say you also try and print out no one. Like when you try and print out these variables, they will both show up as null. Okay, null, null. Now, if you want to compare if something is null to see if something is null, since null is a memory address, you must use equals equals. So if I want to see is nothing null, I can say if nothing equals equals null. And in that case, we could just print out like this is null. Okay, and then if I want to see if something that's not null, so for example, like we know that Herzog and Kirby, those guys are not null. So if I try and see, if T1 is null, then I'm just going to give a spoiler alert, this will not print. So that's all it means, is if something is null, it just doesn't point to anything. So this is null prints, the other one doesn't print. So what's going on from a picture standpoint is that when you set like a person P1 to equal a new person, right? And you fill it out. So it makes this person P1, calls it P1, and it stores a memory address, to some spot in memory where it goes down here, and there's spot 62, and it fills out like the person's name. If you set person P2 equal to null, it sets up a new variable called person P2, and then basically it just puts nothing there. It just says no memory address. That variable does not point to anything. It doesn't link anywhere. It's just by itself right there. So that's what's going on when you set a variable to be null. Okay, so one thing I also wanted to talk about is if you have the null pointer exception. The null pointer exception happens when you try to call a method on an object that is null. So if you try and set up some string, so string nada equals null, and then you try and print out nada dot length, like this is going to cause an error because you're calling a method on nothing. Because what happens here, and first off, let's see the error message. When we run the code, we see the error. It just says, okay, it's a null pointer exception. And the reason this gives an error, because this says, go to where nada is in memory, then call dot length. But that's not going to do anything because nada is nowhere in memory. So you can't go to somewhere and call a method because there's nowhere to go. So that's why it gives you the runtime error. Runtime error, and that's the null pointer exception. A common place you guys might have seen this error is inside a class. If you forget to set up, so here's something that a bunch of people have done. Let's say you have an instance variable for an array list. So private array, and I'm going to need to do an import statement. Let's say you try and set up an array list of strings called grades. So here's one of the common things you'll see. Import Java. I don't know why this is lagging. Okay, so the default type or the default value of an object instance variable is null. So if I don't do grades equals a new array list, if I never set it up to be a new object, this will cause an error. So if I try and call a method on grade, so if I try and do grades.add and I add in like your grade is an A+, you're going to see this is going to cause an error. Not because your grade's not an A+, but when you go ahead and actually try and run this code, what you'll see is it's going to cause an error here. This is so slow. It's going to cause this null pointer error. And that's what this error means, is you never set this up. Right now, grades is null because you never set it equal to a new array list. So that's what's happening. The null pointer exception is happening when you try and call a method on a null variable that's never been set up. Like this nada never got set up. And this is different. This is different than an empty string, right? So if I just do, string empty equals a new string and I put something in it, like this still creates a spot in memory. It creates a new object in memory and then it stores the address to it. It's just blank, right? There's nothing in it. But now if you try and print out, like empty.length, it just has a length of 0. And that's different than this one because this just gave an error because it didn't actually exist. So we run this code here, we see, oh yeah, because I'm really stupid here. That was a different thing. Right, so now when I run this code, I will see it works fine and it does print out that 0. So that's the difference between having something be like an empty string versus something that's null that actually just doesn't exist. So, okay, so that's how null works. That's comparing strings. Thank you guys so much for watching and bringing me plenty of questions to class.